All right, so I want to go ahead and clarify a couple of things because I mentioned this at the beginning of Thursday's lecture / exercise, but I don't necessarily think that it took, right? So for that in-class exercise, I wanted you to turn in what you had, right? Even though if it might not have been fully done, if you turned it in, I wanted to give you credit. So make sure to just turn it in, like, oh, say by tonight. Right, and if you didn't do it, just meet up with just find the person you worked with and have them email it to you, or watch the videos that I posted online. Typically, the Thursday lectures are posted a bit later, just simply because the video files are pretty good, so I need to be on campus to the video files are pretty big, so I need to be on campus to upload those. Now, so, that's an in-class exercise. You didn't have to have it all the way done because we were working on it in class together. And if you found it hard and difficult, that was something normally I give students an entire week to work on. But I figured doing it in class and guided as an exercise would give you an idea about it. So let's go ahead and just talk about, yes? It will be no. I want to see it. This was an in-class assignment. It was basically for credit. So turn in what you have. Yes. So I uploaded more stuff on Monday, and what it was is that I had the bit that I recorded the bit before the quiz and then the bit after the quiz, and that was for lecture 3, and they were just uploaded out of order. That sometimes happens. And then I uploaded the videos from Thursday, and there's 4 of them because I did 4 separate blocks, and I didn't bother to splice them together because that takes time on my part. And they're up there now. Now, and again, for those of you who didn't figure it out, the video on Canvas, right? If you go to videos, it does look like there's just one video, but it's actually an embedded playlist. So if you click on, I think the top left, it will pop up with a list of the rest of the videos, or if you click on the title, it will open up in YouTube. All right, so game plan here is that the next 2 weeks are going to be about functions and loops, right? So functions and loops are basically the focus of the next 2 weeks, and once we're done with that, probably around week 5, so this is week 3 for reference, around week 5, at the latest week 6, we will have our first exam. Because I like to do our exam on target. I like to be very targeted with my exams and give them plenty of time to go over. You will get a practice exam at and it will be given to you about week 4. And the way the practice exams work, if you weren't here for the first day, is that I make twice as many questions, split half of them into a practice exam, half into the real exam, and hand you the practice exam. So it's a very fair representation of what's going to actually be on the exam. Some of the questions are just the same, but with the numbers changed as much as possible, in the coding course. All right, so let's go ahead and talk about functions, right? So if you're coming, so wait, before I continue, any questions? So now let's talk about functions, right? In math, we have these, we learn about writing functions. Like in math, you might do something like, you might get an equation like saying f of x is equal to x plus 3, right? Which means that if I put, 6 in here, the function is going to pop out 9, right? If I put 7 in here, it's going to pop out 10, right? F of x is equal to x plus 3. Whatever I put in for x, I add 3 to it, right? And to give that back. So this kind of functionality exists in Python, but in a much more powerful manner. Functions allow us to add new commands, and I kind of showed you how to do it on the first day, but we're now going to go into more detail. So functions are in chapter 3. And we haven't finished with chapter 2. I'm kind of jumping ahead to chapter 3, but then I'm going to go back and fill in the rest of chapter 2. I find it much easier to deal with this way, especially since with what you have for homework deals with functions. So let's talk about making new commands in Python, new functions. So let's go ahead and put it in you know, let's see, classroom, ITP, func examples. Okay, .py. There we go. So functions are, so first off, to create a new command that you can use in Python, we use the def keyword. Def, and then we say whatever the function is. Print, or print hello, right? And this will just basically say, and what this will be something very basic. Print hello. So this defines a new command that called print hello. And when I call print hello with the open parentheses and the closed parentheses, then the interpreter knows to print hello. So I will go ahead and write print hello. So if I run this program, it just prints out hello. See, can I call it in here? Yep, I can now call it in here. So it defined a new command for Python. As long as this shell hasn't been restarted, it will define the new command, right? So there's a lot of these commands that have already been built in and created for us because they're super important. One of them is the print command. It's just simply, how do you print out stuff? That's a function. Print hello, right? And you notice there's like a whole bunch of ways that I can mess with it too. It says like there's various options. So print hello is a command. I can also go hello. This is 5 args. Hello, this is 5 args. So it split them up. So you can use this print command in multiple ways. You can separate multiple strings or values. Notice that this was not a string, by commas, and it will just concatenate them together automatically for you. Turn them into strings and concatenate it automatically for you. There's also mathematical functions like max, where you can pass in a bunch of numbers and it'll give you the biggest one there is. Right? So max 432, 1467, that gives back 32. That too is a function. Right? That's a command built by somebody else for you to use in Python. Right? And the nice thing about Python, about functions, is that once you write a function, you can package it up and hand to somebody else, or you can reuse it later in a future program. Especially with those mathematical ones. Like, let's see, like min, right? If there's a max, there's a min. 1, -1 gives me the smaller of whatever I pass in. So we can define functions. Now, we know that something is a function and not a variable based on whether or not there's parentheses after it, right? Notice that print hello is, let's go ahead and, so this is terrible. Try your best to avoid a situation where you might do something like this. Right, this is a var. All right, so I'm going to run this now. String object is not callable. So actually, this is actually something where I've done something terrible in Python, right? Don't give a variable the same name as your function, because then it will think that that variable is actually the function and crash on you, right? So don't do that. So we've got this this thing over here called print hello. We can also tell it to, and we can basically make this as complicated or as complex as we needed. We can have a bunch of functions in here. We can have a bunch of things that are printed. But what makes functions really powerful is kind of the operations we've seen with math. So let's go ahead and define a mathematical function. Let's define double this, right? Double this x, right? So and remember, we're in programming. We don't have to be limited to using a single letter like F for our function names. Like, right? If you're dealing with calculus or pre-calc, they're like using F and G and H and X and Y. And it's like, why don't you just give these variables bigger names so I can tell them apart? Oh my God, it gets even worse. Like when they use P and Q or M and N, and now you can't, and your professor has a thick accent, and you're like, wait, did he say M or N? Right? So we avoid that in computer science by having big variable names. So double this X, right? I'm using X here, but X is just simply the standard thing for a number. Can you guess what it's going to do? It's going to print the double of, it's going to print this thing doubled. So print 2 times X, okay? So double this. So notice what it says over here. It's saying it's taking in a variable called X. So if I don't pass in a variable, it says, hey, double this has one missing one required positional argument. An argument is something that you pass into a function, right? It's saying that, hey, double this is supposed to get in a variable X. You didn't pass me an X, right? I need to double something. You didn't give me anything to double, so I can't work. I quit, right? Right? So we got to give it something that can be multiplied. So let's go ahead and give it 5. So what this will do is that this will copy 5. This is very important. It will copy 5 into X and print it out. So hello, 10, right? It print out double that. If I pass in negative, 2325, it will double that. It will also double that and a half, right? So it will work for a float as well because, that's a standard mathematical operation. If I pass in, let's see. Now, will it work for, if I pass in hello, will that work? Hello 4. It will do 2 times hello 4, which if you remember, in Python has the special command of, multiplying a string twice, which is just simply saying, I'm going to do this twice. All right? So it will do whatever it can to do that. Now, mind you, so this is particularly powerful. I can tell it to do something. So, I can write something like this: print message. So I can do something like this: print message. Like this is my message, and I'll print it. It's kind of useless right now, but we're going to build up from it. Okay. So you pass in a message that you want to be printed out, and we'll print it. So I'm going to replace what I have over here. I'm just going to comment it out and move it to the end. Right? And also, the functions can be defined anywhere. Okay, print message, def. Sorry, no, not def over here. Def is to define it. So now we call it print message. Hello, how are you? This will get more interesting, I swear, in just a couple seconds. Okay, so, and this will print it out. Fairly straightforward. It just copies this string over. It copies, or rather, it copies the memory location of the string, but we'll get into that later. It copies this into here, and it prints it out. Okay? So let's go ahead and create something a bit more. Suppose that I want to write something called def spam message. All right? Which, given a message, will spam it a bunch of times. Right? In other words, let's say I'll print the message 5 times. That's spammy, right? Print message, Control V, Control V, Control V, Control V, Control V, right? I'm printing 5 messages here. Everybody see that I'm going to be printing 5 messages, right? And again, it's just like the if statements. We know that these print messages belong to the spam message function because they're indented inside the spam message, right? That's how we know what encompasses the command, because it's indented inside of it, right? We know that these go along with it. So if I do that, now I do spam message foo. Okay. Or spam What did I misspell? Oh, yeah, so that's something that happens, right? Name error, SMAM messages not defined. Okay. Again, I got my PhD in computer science, not English. So, hello, foo, 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 foo. So I printed out 5 times, right? But that was also kind of annoying here that I had to print this out 5 times, right? I had to copy and paste it 5 times. And furthermore, if I wanted to print it out 6 times, it would be really frustrating if I had to make an entirely new function, one that would spam a message 5 times, then one that would spam a message 6 times, and then one that would spam a message 7 times. If I could just spam a message, a specific number of times, that would be really convenient. And it turns out we can do that, okay? So I'm going to demonstrate this, something called a for loop over here, and then we're going to go into that into much more detail. Okay. So let's go ahead and edit this, okay? So, and I promise I will go into, this will probably be the remainder of the lecture is going in on these because they are very powerful. So for x in range, number of times. So this is here, don't worry about this too much because I'm going to go over this in a much more basic kind of way. I'm just kind of showing you what we're building up to. For x in range, number of times, print message. All right, so now if I run this, it will actually crash because it says I'm missing a argument, right? I said, please give me 2 arguments, the message and the number of times you want it printed, right? And then it will print that message that number of times. So I need to say how many times I'm going to print it. So I want to print it 20 times. There, it printed my message 20 times. You can count it if you want to, but I trust it. So let's go ahead and do it a much more countable number of times. 5. Hello, how are you? And then 5 foods. So we've learned about 3 statements so far. So we've learned about 2 statements so far. The imperative statement. We've also learned about the conditional statement. And now we need to learn about the final kind of statement you have in programming, the iterative statement. Imperative statements just simply say, do this, do that, assign this value to this value, print this out, right? Not really making any decisions there. A conditional statement makes a decision. It's an if statement, right? And then finally, the last type of statement is the iterative statement. It says, do this many times, or do this until this happens. Okay, so let's go ahead and look at the first type of iterative statement. Now, there's 2 types of loops in programming languages. There are definite loops, which are what are going to be our primary focus of basically what we get of this week. And for definite loops, you know how many times that something is going to repeat, or at least it tells you. You can figure it out. An indefinite loop is you might not know how long it repeats. An example of this is, is the computer prompting you? Do you want to continue? Yes, no, right? And then looping whenever they use and saying, please enter something yes or no whenever this user enters something that's not yes or no. You don't know how many times the user's just going to mash on the keyboard before hitting yes or no, right? That's an indefinite loop. We're mainly concerning ourselves right now with an definite loop, right? This one definitely prints it out number of times. So let's go ahead and see how a for loop is. The way we read it is as for x in something. Okay? And they're extremely powerful. So for x in range of something. So range is this really interesting function here. It's actually been redefined, and it's one of the main ways that Python 2 works, changes from Python 3. It's actually a special function called a generator, and that's way more information you need to know about. But they're very powerful. But basically what it will do is that will provide values for x. Print x. For x in range 5, it will print out the values 0, 1, 2, 3, 4, and that's it. It prints out 5 values, the values 0 through 1. So if I do something for x in range blank, it will run blank number of times. It's a very powerful mechanism. So if I say to basically, so if I write this in range how many times is this going to print high? Not a trick question. 50 times. It will print it out 50 times, right? Because the range, and what will the values be? Well, x will be the values 0 through 49. Why 0? Because things in computer science, counting in computer science starts with 0. For x in range 50, print x. 0 through 49. Right? So it prints out those variables. It's a very powerful thing. So now let's go back over here to the spam message. So it says for x in range number of times. So this loop will run exactly number of times, and it will print out the message. Right? So this print out the message will be executed once every time this loop occurs. Right? So how precisely does this work for x in range 5? Let's go ahead and look at this again. So the way this works is that we generate basically a condition over here. It says basically we're going to go through this loop and we're creating a variable x that we redeclare at the beginning of every time we do this loop. Print. So I'm just going to write some stuff over here. Print x, print 2x, print done with inside of loop. So let's see what it did there. So so the range provides values from 0 to 5. Sorry, from 0 to 4, right? So we say our first time through the loop, x is going to be 0. So we print out 0 and 2 times 0, which is 0, and done with the inside of the loop. Now that we're done in the inside of the loop, we go back to the pop of loop and we ask, hey, range, do you have any more values for me? And range says, yes, I have a 1 for you. Okay, and x goes, oh boy, I'm now a 1. So then it goes 1. So then it says 1, 2, done with the inside of the loop. Awesome. Then it goes, hey, I'm done with the inside of the loop. Do you have any more values, range? And range goes, sure, 2. And so x goes, oh boy, my value's 2 now. So I'll print out 2 and 4. And then it goes, okay, do you have any more values for me? Yeah, here's a 3. Then it goes, okay, I'm a 3. I print out 3, 6, and now I'm done. Are there any more values? 4, 8. I'm done. Are there any more values? No, we hit 5 now, so we're stopping. And so it goes, okay, we're done. So that's the way a loop works. It basically goes through all the values in a range. Now, in other programming languages, it just simply goes up until we hit a certain condition. But in Python, it likes to iterate over, basically a range of stuff. Now, this statement is extremely powerful and is extremely versatile because you can use it on basically anything. For instance, watch what we can do. S is equal to, hi, my name is Bob. For letter in S, and again, this variable could be anything over here. I just happen to be using it. Now, notice I didn't put a range over there. I'm just simply saying for letter in S. Print letter. And this is part of the reason I like Python, because it's extremely predictable as to what this is going to do. Can you guess what it's going to do? Anyone? Yes?
Every time there's an S in this statement, it's going to print my
it's going to print out letter. So it's going to print out each individual letter, right? Whoops, sorry. Assuming I hit enter. Right? So print out hi, H-I, comma, space, my name is Bob. Right? So it prints out every individual character in there. So a for loop can operate over anything that is iterable in Python. Anything that has stuff in it, it can go over. So strings have stuff in it. It has letters, it has individual characters in it, right? A range has a range of numbers in it. And as we'll learn, lists have lists of numbers in it, right? It can iterate over a file because a file has characters or lines in it, so it can do that. So the for loop is extremely powerful. Let's see. I'm going to go ahead and boot up the browser so we can just open up the textbook, right? You can find more about this in Chapter 2. Let's just go ahead and open it up, assuming that, the Wi-Fi actually decides to work for us for once. There we go. So Chapter 2, it should be in Chapter 2, Flow Control, right? And we should be somewhere around, right? Let's see. Sorry. So it goes over while loops first, but that's okay. I like to go over for loops because because that's what we like to do. They're harder than while loops, but generally, if you can do the for loop, then we know how to. We can basically because the for loops are harder. The while loops seem so much easier by comparison that they're no effort at all. All right. So let's go ahead and have some fun here. Right, so if you remember from the first lesson, part of what we were doing was ASCII art, right? Right, and I was just doing simple stuff like this. Def like triangle, and this would basically print out and basically I would print out an ASCII triangle in the first lecture. 1, 2. Right, it would be like something like this: 1, 2, / / 1, 2, right? And then I'd adjust this based on how tall, basically, like this. But I had to manually code every part of the each part of the triangle, right? And the triangle ended up looking like this. Right, everybody that remember that from the first lecture? Right? For those of you who were here. Yes? The what? Oh, sorry. That was me mistyping because I'm teaching 2 different languages right now, so I sometimes accidentally do what I do in Java. All right. So def triangle. We've got ourselves a triangle here. Now suppose though that now the only issue with this is that it creates a triangle that is only 3 high, which is a bit of a bummer, right? So what if I wanted to print a triangle that was bigger, like much bigger, right? Again, we run into the issue of, do I have to make something to make a triangle of every size? No. So this is a triangle. Let this be a triangle of height 3, right? So let's analyze it. A triangle of height 3 has how many characters in it? It has 6 characters. 1, 2, 3, and then these backslashes are, right, 1 backslash. 4, 5, 6 to the end. Although the ones to the end don't really matter, right? Let's look at this one. 1, 2, 3, 4, 5, and then 6. If we lined it up with this one, and same with this one, right? It's the last character over here. So a triangle of height 3 is 6 wide across, and it's 3 lines down, right? So if we want to automate this process, we can know that basically we need to do if we want a triangle of height 3, we need 3 print statements. All right, and then we have to and the way it would work is that we would print out like however many spaces we want beforehand, and then our slash, then however many spaces need to come between the 2 slashes, and then the end slash, and then however many spaces come afterwards. All right, that's kind of what we would want to do there. So let's go ahead and see how we can automate that problem. So let's go ahead and write something called define a triangle of height, of a certain height. So for this, we're going to use a for loop. So for x in range height, because we know we want a certain number of things. We want a certain number of lines. So each iteration through this loop will go ahead and produce a specific line. Now, one of the other things I should mention here is that we'll also be learning a new use for the print function, which is that by default, what happens is that with a print function, we tell it that by default, right, when I write print, thing, it will print out thing just like that, and then it will create a new line, right? That's one of the nice things about print. It automatically moves you on to the next line. However, you can actually specify what you want to come at the end of it. So if I say like this, end is equal to, so this is a special functionality. Well, you don't need to know how to make this for your own functions, but this is pretty nice. End is equal to egg. Rather than ending the function with a slash, rather than ending my new line with a slash n, it's going to end it with egg, thing egg. And then it just automatically moved into the next line, I guess, because of that. But let's go ahead and print thing again, just to show. New line, print thing. I think it might actually work better over here in the interpreter. Sorry, outside of the interpreter. So if I do, let's say, print spam, and then I use end is equal to, we'll go ahead and set it to a slash t, a tab instead of a new line, print egg, a slash end, nothing there, and print done. And let's see what happens. Okay, this was from our previous message call. So spam, we printed out with we said let's do that with a slash t at the end of it. So rather than moving on to the next line, it went ahead and did a tab after that. And then we said to print out egg, and after that should come nothing. So it didn't do anything after that. And then we printed out done, which just simply which goes ahead and does the new line for us. Of the time to use an end, this is the most common reason to use it, which is to make sure that we have other stuff to print out, right? But we don't necessarily want to do that yet. So let's go ahead and see over here what we can do. So let's go ahead and go back to our triangle now that we've got this. So we know that that printing out a triangle has 3 components, right? We need to print out the number of spaces before a line, the number of spaces, we need to print out a slash. So we need to print out some number of spaces. I don't know how many to print out though. We need to print out then, yeah, I'm going to go ahead and just comment this out so we have it for a reference. Print some number of spaces. So we have some number of spaces. We have a slash. Print, we have more spaces. And we have the backslash. forward slash. And print. And then there's more spaces after that, but since you can't see those, they're not really too important. But if we go ahead and just run this and do triangle, let's go ahead and, I'm sorry for moving so quickly. I'll go back up to it in just a second. But if we go ahead and print this out, it's not really going to look like anything pretty. Right? Print. Sorry, no. Triangle 5. Oops. Yeah, I have to be able to spell it correctly, of course. Okay, so that's a bit of an issue, right? I did 6 print line statements everywhere. So I have to fix these. So and is equal to da-da, right? If I want them to be on the same line. So Control C and Control V, by the way, your friend. Learn to use them very quickly. If you're on a Mac, that should be like the command key, I believe, as opposed to Control. F5 to run it. So now we print out 5 identical lines. It's not as many as I would like. Let's go back and talk about 3 because I know about 3. Now, this is where it gets fun and interesting. On the first line, I know that I want to be able to print out the I want to print out 2 spaces basically before I want to print out 2 spaces before I print out a slash, right? Then I want to print out on the next line only 1 space. And then on the last line, I don't want to print out any spaces before the slash, right? That makes sense to everybody? So I want 2 spaces here, 1 space here, and 0 spaces here. Any suggestions on how to do that? Do I have something that changes every single line? Every time through the loop? Is there something that's going to change every time through the loop? Do I have some variable, perhaps, that will change every time through the loop? Yes? I don't need to actually change x, but I do want to use x. Yes, because x is what's going to change, right? X automatically changes. It's going to be 1, it's going to be 0, then it's going to be 1, and then it's going to be 2. All right, so actually, let's just go ahead and see, right? What if I multiplied by x over here? That'll be interesting. I got something that changes over here, right? Ooh, let's go ahead and just experiment, because experimenting is good. X times x times x, right? So let's go ahead and see what happens here. So over here, x is on the first time through, right? X is 0, right? Because what's the range? It's 0, 1, 2. So we do, 0 times, so space times 0 is nothing. We don't print it out at all. So then we print out a slash. Then we print out no space. Then we print out a slash, and then we print out no spaces. Second line, x is 1, so we print out a space, a slash, a space, a slash, and a space. Third line is 2, so we print out 2 spaces, a slash, 2 spaces, and a slash. I think we can manipulate this, and I'm not. Of course, I would say that because I have a clear end in mind, right? So let's go ahead and see. So that actually makes sense for over here, for this one, for the middle over here, right? If I remove this over here, let's just take a look at this, right? 0, 2 spaces, 4 spaces. 0, 2 spaces between the slashes, 4 spaces between the slashes. So if I run this, let's just take a look. 0 spaces, 1 space, 2 spaces between the slashes. What do I want? I want 0, 2, 4, right? So let this be line 0. I want 0 on line 0, I want 2 on line 1, and I want 4 on line 2. I want twice the value of the line number. in between those two spaces. So what could I put here? Sorry? Not 2 to the x. X squared is still a bit too much. 2x. 2x. 2 times x. Boom. 2, 4. Because if you did x squared, it would be 9 on 3, but it would work for line 2 and so let's go ahead. So we've now got an equation here for the number of spaces between these guys. If I switch this triangle of height 5, right? I get 0, 2 spaces, 4 spaces, right? Now I just got to figure out how many spaces I need over here, and this one's just only slightly tricky because you got to use subtraction, right? So I want 2 spaces on line 0, 1 here, and 0 here. So I want 0 on the last line, but x goes up, right? And I want the number of spaces I have going down to go down, right? So I need to multiply it by something because that's the number of times I want to do it, right? And I don't just want a constant number because, again, that's going to just get me back to where I started. And it's not going to be 2 times x because that just makes it really jagged and not going to do that. So, right? The number of spaces are increasing here. I'd like it to decrease. So what I can use over here is that I have another variable. Height is the number of lines I'd like, right? So height is 2. So the height is, I'd like 3 lines, and I want 2 spaces here, 1 space here, and 0 there. So to get 0 over here, I'd want to be able to subtract height minus what to get over here? If height is 3, what do I want to subtract from height to get 0 spaces here? 3. How many would I want to subtract here? 2. Subtract 2 over, and then subtract 1 over here. So I can do height, and it's okay if you aren't getting this yet. It takes a bit of practice, which is the next assignment, by the way, to get your head around this one. Height minus 1, let's see, height minus x. Let's see if that works. Height minus x. Ooh, height minus x seems to work pretty well. Almost exactly what we wanted. Close enough for government work, right? Because I don't have 0 on the last line, I have 1, right? I have 1 on the last line, 2 over here, 3 over here, 4 over here, 5, 6, 7. So it looks like I just need to subtract 1 more value, right? Any suggestions on how to do that? Yeah, I could subtract 1, or I like to do x plus 1. Subtract 1 more, or you could do it x minus 1, right? Either way, you just make sure you subtract 1 more. There's a lot of different ways as to why that works. So there. So now I can do a triangle of whatever height I want. This part's the hardest part, generally. And this is where we're building up to. Yes? Can I use what? Fractions? To, print out a fraction line? I don't think so, but let's go ahead and see. Right? Because here I can do times height. Here I'm just making it into a half. I think it's going to crash on me. It says you can't multiply it by half. I mean, there's some languages support half characters, but generally not. So, but it's a good question, and I didn't know the answer to it. And my instinct was no. But you got to test these things out. So this is interesting. So this is kind of the power of for loops. Let's go ahead and see what we can do with it some more. Right? So there's a lot of powerful things we can do there. Let's see. How much more time do I have? Plenty of time. Again, it's really easy to write these things in there. So let's go ahead and talk more about, so this is where we're going to build, what the kind of stuff I want you to build, you need to be able to build up to for your homework. Okay? And you'll have a while to do that. And I fully expect us to have in-class exercises on Thursday to go over this kind of stuff. So let's go ahead and talk about let's go ahead and look at some more things. So more examples. So new, I'm going to create a new file, loop example, because it's getting a bit crowded over there. .py. All right. And this one I'm not going to bother using functions. I'm just going to write some for loops to print them out, right? So let's go ahead and see what kind of things we can do now that we know that this variable is actually a variable that changes between lines. So for x for x in range, let's see, 0 to... So you can do some powerful things here, right? X for x in range is equal to 100. We can do a couple things. We can combine these with if statements. So say I want to print out only the numbers that are divisible by 7, okay, between 0 and 99. So I can do if x. How do I test if a number is divisible by 7? Mod. So right, if I divide it by 7 and there's no remainder, print x. So this gives me all the numbers that are divisible by 7 that are less than 100. In case you ever really wanted to know that, right? Right? I'm sure that was a burning question in your heart, right? All the numbers that are less than 1,000. Your computer spits that out really quickly. All right? So you can combine these with if statements to do things. We can also modify these variables. Like we can print out all the numbers, all the squares. So print, how do I square x in Python? Right? It's not, it's not this. It is that. So this is all the numbers squared 1 to 1,000. Right? And it does take a bit of time to print out in Python, in idle, because your shell's actually a bit slow at printing things out. So that's 9999 squared, in case you, again, ever really wanted to know. All right, so let's go ahead and now, if you've also noticed that whenever I print something, let's go ahead and I'm going to reduce this to 10, right? So if you also notice when I was typing, it says for x in range, and then it will say, hey, you've got range stop, but you also have range stop step. So there's actually multiple ways I can do this, right? Range always starts with 0, but we don't always want to start with 0, right? Right? It was doing 0 through 10, but sometimes I don't want all those numbers. Sometimes I'd like to start with a different number, right? Maybe I want to do, 10 to 20. Let's go ahead and see that. So remember, this range is going to be inclusive exclusive, because everything is in Python is, if you have a range, it's going to be from the beginning to the end, inclusive exclusive. Let me go ahead and print a divider, sorry, just so that we can have so we can see where our answers start, right? 10, 11, 12, 13, oh, and I forgot that. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, right? It gives me all the numbers from 10 to 19. How many numbers did it give me? It gave me 10 to 20 of them, right? So that's actually fairly powerful, right? Now there was this third optional thing called step. So any guesses as to what it's going to print out if I put a 2 there, based on what it's called step, right? Without it, it was printing out 10, 11, 12, 13, 14. Any guesses for what it's going to do if I do 2? Yes? Every second number. It's going to do it out by 2. Python, one of the things I love about Python is that the documentation for it, when you read it, it can be predictable. So this is nice. 10, 12, 14, 16, 18. Stop when you get to 20. Don't print it out. Right? That's pretty nice. All right. Now one more for that range, because there's a reason why we do it this way. 20, 10. Any guesses as to what this is going to do? It's going to go backwards. What numbers is it going to print out? 20 through what? 20 through 12, 11, or 10? 11, right? Because we stop when we get here. I believe. I've been known to be wrong. But there we go, 11, right? So you can go backwards too, which is pretty nice if you want to do something like, you know, right? So if you want to, so this one will print out 20 through 0, and we can do something like this, str x t minus. Okay, right? Count down from 20. And now we will do t minus 20. Oh, right? T minus 20, 19, 18, 17, 16, all the way down to 1. Again, this is a very powerful, these for loops are very powerful for the range. Any questions so far on the for loop? All right. So again, I believe that the best way to do programming is by doing, and me droning up on here for 50 minutes, at least, it's got to be an hour of 20 minutes, right, for the class. But me droning on for 50 minutes, I know strains the your attention span, even though I do try to be as amusing as possible. So let's go ahead and talk about your homework. The next couple, so if you're feeling, oh my gosh, this looks like this is complicated, congratulations, welcome to computer science. It feels like that when you learn something new. But I should also inform you that many of you are probably suffering from something called impostor syndrome, which means that you probably believe that everybody else in the class is getting it and you're the only one who's lost. If you feel this way, please know that this is not true. Everybody's lost. So, right? So, it's very common to feel like you're the only one who's not getting it. And I need to reiterate, this gets better with practice. So I'm giving you 5 small assignments this time around to practice. So these are adapted from my Java program, and I think I'm going to edit it slightly so you don't have to use nested loops. I think I'm going to do that, or I might keep this one hourglass, so that you do have to use nested loops there, because we haven't gone over nested loops. I might go over that on Thursday, so yeah. All right, let's go ahead and talk about this. So for each of these following problems, there's 5 of them, you're going to write a function that solves the problem. You want to demo each function you write by calling it a function called main, right? So let's talk about that for a second. Many programs, when we write a program, a lot of times it's just useful to organize everything into a single function as a starting point, right? So typically the way we do that is that I'll write a function called main, and this is what I write all my commands here, right? Print my program starts here, and I call everything in there, right? So if I write a function, I'll call it in main. And then to start the program, I have main down here. And so if I have a function, I will just simply, so let's see, do I still have that other window open? Right, so if I have a function called print hello that I wrote, and I want to call it, I'll call it in main, like so. Right, you can have functions call other functions. Like that. Main says my program starts here, print hello. And we run it. It'll run the scripts we have above, and then it will say my program starts here and hello. And the reason I like to do this is it makes it very easy to just go to main to know where your code starts, and then turn on, and then you can turn on or turn off code, functions by just commenting them in or out over here, whether or not you call them over here. So you'll want to, so why do I mention this? Rather than making 5 Python files, make 1 Python file this time with 5 functions in it. Okay? 1 Python file with 5 functions in it. Okay. So here we want to so the first problem, we want to write a function that uses a for loop to print out the lyrics of the infamous 99 bottles of beer on the wall drinking song, which, starts off basically 99 bottles of beer on the wall, 99 bottles of beer, take one down, pass it around, 98 bottles of beer on the wall. And then it just continues. It's a very boring song, but I don't know if that was ever fun. But anyway, we don't want it to print out 99 every time. We want to have it start at a specific point. You should take in integer. You should take in an int as a parameter. So take in some number, and start the lyrics from there. So if we give it 10, we want it to start 10 bottles of beer on the wall, 10 bottles of beer. Take one down, pass it back around, 9 bottles of beer on the wall. Right. So the important thing to hear is that so say we were writing this over here. I'll go ahead and show you what I want for the first one, just so that there's no confusion there. So the way this would work is that you would write a function, maybe, define bottles of beer, or whatever you want to call it, drinking song, or just song. It will take in n. So let me show you what I do not want you to do. Do not do this. I don't want to take user input from here, at least not in bottles of beer. Okay? If you're going to take you don't have to do that. You can just hard code, I would like to call bottles of beer with, however many. Like, maybe I want to start from 4, right? And if you want to change it, you can just go into your program and change it. Right? You don't have to make it interactive. If you do want to make it interactive in main. Right? Beat. Beer. Is there confusion about that? Right? You don't have to make it interactive. You can set whatever number you want, but we just got to pass it over here. Right? This should print out plus str n So there's 2 correct ways to do this, to reiterate. The first correct way is just simply to hard code it, right? This should print out 50 lines, right? And if I want to change it to 150 lines for some reason, I change it to 150 over there. Or over here, I go num bottles is equal to input. And notice that I'm in the main function. How many bottles? Surround it with an integer, right? Because we're going to turn it into an int. And then turn this into num bottles. Both of those ways are equally correct for the homework. Assuming, you can name your variables correctly, like I failed to do right there. 10 bottles. This should print out 10 lines. Right? This test says num bottles over here, num bottles over here. And notice that's num bottles over here and n over here. Okay? How does that work? Why does that work? Well, what it does is that it takes the num bottles, which was 10, it takes 10, copies it into n, right? And then it uses n over here. right? It takes out the value, so the names don't have to match. Okay, so, and that's another thing to note. I define something called n over here. It only exists inside this function. Same over here. If I create a variable in this function, it should only exist here. Well, that might not be true for Python. It's true for every other programming language. We'll get into that with scope. I seem to remember that having some issues. All right. So, yes. They don't have to. You can copy them. You can comment them in or out as need be, right? But we would just like this in one file, just simply because it's easier. That way, you don't have to juggle around 5 files, right? Which can be a bit tedious, right? And they're small, and they're relatively small. They only appear super big because I'm using huge font. So number 2 is to create a multiplication table. So with, your standard thing you might see in the back of a notebook, right? A 3 by 3 multiplication, like here's everything multiplied by 1, here's everything multiplied by 2, here's everything multiplied by 3. Summation of squares, write a function which, given an integer n, uses a for loop to print out the sum of all numbers squared from 1 to n. This is something we're going to call a running sum, and we'll tackle it a lot of times throughout the semester. So if we pass in 5, it will print out 1 squared. It will print out 55 because 1 squared, 2 squared, 3 squared, 4 squared, 5 squared is 55. And then we have 2 ASCII art things to do. The first is the hourglass, which, wouldn't you know, it looks like an ASCII art hourglass. This one, I want you to write a function that prints this out, but I want you to use for loops, specifically nested for loops, which we'll talk about, if not today, then on Thursday. Nested for loops. So print out that one exactly. Yes?
For the hourglass, does it even have one main for loop and then a bunch of for loops nested in it?
That's the idea. And we haven't talked about nested for loops, but we still have, 15 minutes. So, and now the slash function figure, which this one produces another ASCII art figure of differing size based on what your input is. So with that, let's go ahead and talk about nested for loops, right? And in Python, the reason I specify nested is because you can get in other programming languages, this actually would have required a bunch of nested for loops to do this function. In Python, you don't need that because I can multiply by a string, which is super convenient. All right, let's talk about a nested for loop, though. Nested for loops are very interesting to look at. Let's go ahead and write one in a new file. Nested.py. All right, for int, so for x in, I'm going to call it for x in range 5. So x's values are going to be what? 0, 1, 2, 3, 4. For y in range x. Let's start out here. For y in range x, print exclamation point. So anybody want to tell me how many total exclamation points are going to be printed out? 25. 25. Now why is that? Well, because this loop, the one from the x, the one that says for x in range 5, this is going to run 5 times, right? It's going to run 5 times total. But the one inside, that's going to run each time this goes through the loop. So this is going to run once when x is 0. This is going to run this is going to run 5 times when x is 0, 5 times when x is 1, 5 times when x is 2, 5 times when x is 3, and 5 times when x is 4, right? For a grand total of 25 exclamation points. Perhaps if I maybe make it like this, it will be more apparent. End is equal to boop, boop. And then what I'll do over here is at the end, I will say print nothing. Right? So the X loop, the outer loop's role is job is I'm going to print out. It says I'm going to print out. Sorry, I'm gonna run this inner for loop, and when it's done, I'm gonna print a new line. And the inner for loop says I'm gonna print out 5 exclamation points. So it spits out 5 exclamation points, then it spits out a new line. 5 exclamation points, spits out a new line. All right? Everybody kind of following that? All right, so this is where I lose people. And don't worry if you get lost. For range in 5, y in range x. Let's go ahead and change the variable names. Where a bang is a exclamation point. So for num bangs in range 5. So what are the values for num bangs? They're going to be 0, 1, 2, 3, 4. So the first time we go through the loop, how many bangs are going to print out? Zero. Zero, because it's a bit of a trick question because I haven't told you what happens if we put 0 in the range here. If we put 0 in the range here, nothing happens, right? Because it stops because we hit 0. We start at 0 and we stop because we hit 0. So I put 5 here. So 0 will be the initial value here. So nothing. Print out a new line. Now second time through the loop. Num bangs is 1. So how many bangs will print out? Not trick question. 1. Okay. So now, and num bangs will be 2. How many will print out? 2. Then it will be 3. So how many will print out? 3. So 0 printed out, then 1, then 2, then 3, then 4. Right? It will print out exactly as many as you tell it to. It looks a bit complicated, but once you think about it, it says, oh, so this will be the values 0, 1, 2, 3, 4. Now, you might be thinking, oh God, how do I analyze these things? How do I do this in my head? And the answer is you don't until you've gotten a bit of experience doing this, which should be within the next couple weeks. For right now, the way to do it is to use the most valuable tool in a programmer's arsenal, which is pencil and paper. Basically think, okay, so num bangs values are going to be 0 through 5, so I'll write that down. So y's values are going to be 0 through 0, stopping at 0. So I write down that, and we stop, so I don't print out anything. Now go to another line, right? Run through it in your head using your pencil to update the state, right, to remind you where you are in the program. Running through it with pencil is one of the most valuable tools you can use. Let's go ahead and now do 1 plus num bangs. So how is this going to change this one? How many are going to be on line 1 now? It'll be 1 plus what? 1 plus 0. Right? The very first line will have 1 plus 0, which will be total of 1. The second line, num bangs will be 1 plus 1 for a grand total of 2. So here we can get 5 printed out. All right. Any suggestions on how to go backwards? Say I want to do 5, 4, 3, 2, 1. Yes? It's an excellent suggestion. 5 minus num bangs. Yep, that'll do it. 5 minus num bangs. That'll do it, right? Because I want 5 on the first line, and we'll subtract 0 from it because we start num bangs at 0. Then 5 minus 1. Then 5 minus 2, and so on and so forth. This was not the only way to do it, but it was one of the ways I was thinking of. There are a couple ways to do this one, because these things are, again, very easy manipulated. Any other ways to do it? Can we do it manipulating the outer loop? Yep.
You could do like from 5 to 0 and then -1.
Yep. We can start from the right. We want 5, then 4, then 3, then 2, then 1. Right? So rather than counting up and subtracting, which subtracting is a bit, hard to get your mind around, right? If you remember for this one, it was a bit weird because we have to subtract the height, and we were doing height minus x plus 1, which is really weird. Well, it made sense that here, if I want to do 5, then 4, then 3, then 2, I can just start, I can just operate it like this. Right? I want 5 numbangs in the first line, then 4, then 3, then 2, then 1. That makes sense to everybody? So nested loops aren't too scary. Now, again, this is your textbooks cover this in Chapter 2. And they cover this primarily... let's see. I think this textbook just covers our textbook just covers singular loops. I know the other textbook I have goes over nested loops. But your TAs will be there to help, and I will be there will specifically. I think what we'll do as an in-class assignment is we'll specifically work on problems that are similar to this, if not the homework problems themselves, while in class on Thursday. So you guys can get some help with that. All right? So I feel like I'm good and done for the day since everybody else has decided that. So, all right. So come up and speak to me if you want to demo something or if you want to ask questions. And please, if you did the thing on Friday, which I know on Thursday that I know a lot of you did but didn't turn it in so I can give you credit for it.